Hi, my name is Patrick Keyes, and I'm a researcher with the Stockholm Resilience Center. And today we're going to talk about precipitation sheds. But before we get into that, where does rainfall come from? So today it's raining in Stockholm, it's gray out. And where did this rain come from? We know it came from the sky, but we also know that somewhere on the planet, water evaporated. It traveled through the atmosphere, and now it's falling out as rain here in Stockholm. And it's this critical idea of rain evaporating, traveling through the atmosphere, and falling out in a certain place that is the core of this idea of the precipitation shed. And the two words that come together to form this idea, precipitation, rainfall, and shed, gets at the idea of the source area that contributes the moisture that eventually falls out as rain. And so a precipitation shed can be thought of in the same way as a watershed. On the surface of the earth, we have water that runs off the land and flows to a certain point. And we can think of that entire area as the watershed. Well, a precipitation shed is the same thing, except it's for the atmosphere. A critical difference is that it includes both the atmosphere and the land, this three-dimensional space. To get at this idea in a different way, I'm going to draw a simple diagram. And so right here is a rainfall sink. It's a specific location, for example, Stockholm, that receives rainfall. And that rainfall, or precipitation, P, comes from evaporation somewhere upwind, E. It turns out that it's not just one place. It's E from lots of places. But the critical difference, or the critical thing about the precipitation shed, is that it captures all of those regions. And it starts to allow us to talk about all of these places that are contributing evaporation as source regions to a specific location. Another way to think about this, to take it to a more important example, or a more realistic example, aside from this conceptual diagram, is to look at a place that is very dependent on rainfall for its survival. A place like Stockholm doesn't need all of the rain it gets. A lot of it runs off, and a lot of it flows back to the ocean, which isn't a bad thing. But there are a lot of places where the entire economy is based on precipitation. And a place like Burkina Faso, where most of its economy is based on agriculture, particularly rain-fed agriculture, rainfall is the difference between life and death. So here is the outline of Africa. And here is Burkina Faso, a sink region. And in this sink region, it's growing crops. This crop is not to scale. And this crop requires a certain amount of rainfall, or again, P, which during some seasons is a lot. There is a lot of evaporation that is traveling through the atmosphere to fall as rain. And that evaporation, though, since it's largely coming from the continent, a little bit from the ocean, but mostly the continent, all of this evaporation is coming from different land covers. So in some places we have mountains. I won't draw all the little details, but we have mountains, we have rainforests, we have savannas, and all of these different places have different amounts of evaporation. Now, humans can't really change the ocean's evaporation rates, maybe through global climate change. But we can really change the amount of evaporation on the land surface by chopping down a forest or by turning a desert into an irrigated landscape. And so one of the things that we are going to try and do with this concept of the precipitation shed is to better understand what happens. What happens when we chop down those forests? What happens when we irrigate those deserts? How does that affect, and where does that affect, rainfall downwind? Thanks a lot.